Right, this is one of those graph questions that everyone enjoys so much, where you have to work out what's going on with the graph and the extra lines and blah, blah, blah. So we've got x cubed minus 7x plus 9 drawn, looks like that. And it says the graph of y equals x cubed minus 7x plus 9 and the line with equation y equals k have 3 points of intersection. Now, if y equals k, that's like y equals 2, y equals 7, y equals 23. And whenever you got y equals something, you get a straight horizontal line. Equally, if you have x equals 2 or x equals 4 or x equals minus 23, you get a straight vertical line. So it's saying this graph and a horizontal line have 3 points of intersection. Now, if I draw a horizontal line like that, deliberately not putting it on the graph, if I move this line, at the moment, you can see when it goes through y is 20, it intersects the graph only once. Once. At the point where this graph peaks, it's now touching twice. And then in this range, there are now 3 points of intersection between my line and the graph. So this is a horizontal line, y equals something. And now here it's 2 again. And if I bring it further down, now it's only intersecting the line once again. So what it's asking for is the values of k, the intersection values for which this line cuts through the graph 3 times. So it's between here and here. Now it's kind of hard to read off the graph from this screen, but I'm thinking that that is just below the peak at 16. So I'd say 16 is my highest value. And it's hard to tell whether at 2 it has 3 points of intersection or not, because if it's just touching the line, that's only 2 points of intersection. So I'm going to go for 3. So I reckon it's between 3 and 16. Anyway, the bottom bit isn't relevant because it's asking for the greatest possible value of k, and that's up here. And although I can't see exactly, I think I'm going to go with 16 for that. Here's the line y equals 16. I know it looks like it's going through 15. Maybe I should move it up a bit. Here's the line y equals 16. Move. There you go. Okay. And it goes through the graph here, here, and here. So 3 points. Yes. Anyway, here's that question that you always get where you have to draw a suitable line on the grid to match the equation here to the line you've drawn. So here's how I suggest you always do it. You write out the equation that you're given in the question. Minus 6x minus 2 equals 0. It's an equation because it's equal to 0. And then you write out your function. So that's the graph that you drew originally and that you made equal to y. You write out underneath. But instead of making it equal to 0 or equal to y or anything else, you make it equal to the mystery amount which you need to work out. So what you work out here is going to be the line that you draw. Now, what did you do to get from your equation to, what did you do to get from the line to your equation? I know this is the bit that confuses people. The important bit is the equation has information on both sides. It has x cubed minus 6x minus 2 on the left side, and it has 0 on the right hand side. So it's a question of how we get from this 0 to the line that we're going to draw. Well, to get from the equation to our original function, we've gone from minus 6x to minus 7x. We've gone down by x. And we've gone from minus 2 to plus 9, so we've gone up 11. So effectively, the line we're going to need to draw is minus x plus 11. That's a line with gradient minus 1. It's a linear, obviously, because it's a straight line. So gradient minus 1 that goes through 11 on the y-axis. So if we go to 11 on the y-axis, and we go down 1 every time we go across 1, note the difference in the scales mean that it's not going to be a 45-degree line. So it's going to be 10 when x equals 1, 9 when x equals 2. I've drawn this really badly, but never mind. 8 here, 12 here, 13 here, 14 here. I'm just drawing a line that goes down 1 every time you go across 1. I'm going to draw that line in now. And goes through 11 on the y-axis. And there's our line. And so where our original curve meets this line, the original curve is in red. Let's make this really messy by drawing all over it. So there's our original curve, beautifully traced. And where our original curve meets this green line, so here, here, and here, I've made that really clear now, obviously. Those will be the same solutions as the blue equation. could draw out the blue equation, and basically where the blue equation would go through the x-axis, where the blue equation would equal 0, would correspond to the same values, x values, where the red and green lines meet. So what are those x values? Well, that looks like about 2.6, that's about minus 0.2, and that's about minus 2.4, something like that. Remember, we're writing down the x values, and that's the solution.